this video I will explain the classification of circuit breaker and the oil circuit breaker. Actually, the circuit breaker, it consists of two conduct. One is fixed conduct and second one is moving conduct. And when the fault occur, this moving conduct is pulled away from the fixed conduct in an insulation medium. So based on the insulation medium, we classify the circuit breaker into different category. Suppose the insulation medium is oil. Such kind of circuit breaker is known as oil circuit breaker. And the medium is air, means such type of circuit breaker is known as air circuit breaker. In some type of circuit breaker, we are using SF6 gas for insulation medium. So it categorized into SF6 circuit breaker. So based on the medium, so normally the medium in the circuit breaker is used to quench or extinguish the arc between the contact when the contact opens. So based on this medium, we classify the circuit breaker into several categories. So these are oil circuit breaker, air blast circuit breaker, SF6 circuit breaker, and vacuum circuit breaker. So first one is oil circuit breaker. So in oil circuit breaker, the insulation medium, the oil which acts as an insulation medium. So the first I will explain the basic construction and operation of oil circuit breaker. So figure 19.2 shows the construction of an oil circuit breaker. So in this construction, in this oil circuit breaker, it consists of two conduct. One is moving conduct and second one is this is for the fixed conduct. Second one is moving conduct. And these conduct are placed in a insulation medium. Here it is an oil. So this dot indicates the oil surrounding the contacts. So when the fault when the normal condition, the two contacts are closed together. So that it carries the normal current through the circuit. When the fault occur on the circuit, then the moving conduct, it gets separated from the fixed conduct and a gap is created between these conduct. So due to this gap and also due to the high voltage, a arc is struck between these conduct. So this arc again it allow to carry or to flow the short circuit current through the circuit. So the main duty of this insulation medium, here it is oil, is to extinguish the arc as soon as possible. So when the arc is struck between the contact, along with the arc, a heat is generated along with this arc near the surrounding oil. So that hydrogen bubble is generated near the arcing location. Okay. And the hydrogen gas occupies the volume of about 1000 times than the oil. So the volume of hydrogen gas is very higher than the oil. So that oil pushes. So this oil pushed away from the arc and arc is extinguished. So that is the normal working of a oil circuit breaker. And the oil circuit breaker also can be classified into different category, but the operation of oil circuit breaker is same. The operation is the hydrogen bubble is produced and the volume of hydrogen bubble is larger than the oil, and this hydrogen bubble which pushes the arc between the contact. That is the operation, and operation of circuit breaker, oil circuit breaker, is same in all type of circuit breaker. Only thing is the construction wise it varies. Okay. So now we move to the classification of oil circuit breaker. Before that, the advantages of oil circuit breaker. Okay. So oil, it absorbs the arc energy. So oil, it absorbs the arc energy. Okay. It absorbs the arc energy. So that because the oil is an excellent cooling property. That is first advantage. Then second advantage is it acts as a good insulator. Okay, oil, it acts as a good insulator. And disadvantage is oil is an inflammable material. So there is a risk of fire, and it also it form an explosive mixture with air. And the major disadvantage is the arcing product. Okay, so after the arcing process, the byproduct is formed. So the byproduct of the arc remains in the oil. It remains in the oil. Okay, so it deteriorates the quality of the oil. So that is the disadvantage of oil circuit breaker. Now we move to the type of oil circuit breaker. So the oil circuit breaker, mainly it can be classified into two. First one is bulk oil circuit breaker. First one, bulk oil circuit breaker. Second one, low oil circuit breaker. Okay. So bulk oil means a large amount of quantity of oil is used. Okay. Whereas low oil or minimum oil, it also known as low oil or minimum oil. So it only consists a minimum level of oil. And bulk oil circuit breaker can be classified into two. One is plain break oil circuit breaker. Second one, arc control oil circuit breaker. Okay. So we can see first one, plain break oil circuit breaker under the bulk oil circuit breaker. So this is the figure 19.3 that shows the plain break oil circuit breaker. Okay. So in this that comes under the bulk oil circuit breaker. So that means large quantity of oil is used. So in construction it consists of two contact. One is fixed contact. This is the first set of contact, fixed contact, and bottom position. The another contact is there, that is moving contact. Okay, and that is immersed inside the oil. Okay, and normally during the normal condition, the both contact are close together. Okay, and current flows through the circuit. And when the fault occur, this moving contact pull down, and a gap is created between the fixed and moving contact, and due to the high voltage, an arc is struck between these two contacts. So along with this arc, heat is generated near the surrounding the oil, and a hydrogen bubble is produced. And the volume of hydrogen bubble is higher than the oil, and this hydrogen bubble that extinguish the arc between the contact. That is the working of plain break oil circuit breaker. Now we can discuss about the advantages of plain break circuit breaker. Okay, so here a bulk amount of oil is used, so it cools faster. Okay, and oil which act as a turbulence. Okay, so and it helps eliminating the arcing product, and then that is the advantages of a plain break circuit breaker. And disadvantage is no special control over the arc. Okay, and second one, these breaker have long and inconsistent arcing time. Okay, long and inconsistent arcing time, and it do not permit high speed operation. So this type of breaker is used up to the 11 kV voltage. Okay, so above 11 kV we use other type of circuit breaker. So that is plain break circuit breaker. The second classification of bulk oil circuit breaker is arc control oil circuit breaker. Okay, arc control oil circuit breaker. That is the second classification of bulk oil circuit breaker. So arc control oil circuit breaker, again it classified into two. One is self blast oil circuit breaker, forced blast oil circuit breaker. Okay, self blast and forced blast oil circuit breaker. So first I will explain the self blast oil circuit breaker. So self blast oil circuit breaker also can be classified into three. Okay, so self blast oil circuit breaker can be classified into three. First one is plain explosion port. That is the first classification. Second one, cross jet explosion port. Third one, self compensated explosion port. Okay, so first we explain the first classification, that is plain explosion port. So figure 19.4 shows the plain explosion port. So the plain, in construction wise, in plain explosion port, it is a port. Okay, and at the bottom place there is a small opening that is known as throat. Okay, and there are two contact, fixed contact that place the upper part of the port, and moving contact. Okay, so normal condition, the moving contact and fixed contact are close together. Okay, so when the fault occur, this moving contact is tried to pull down from the fixed contact. Okay, so a gap is produced and arc is formed, and along with the arc heat is generated, and this heat is cause the hydrogen bubble, and it extinguishes the arc between the contact. Okay, and in this moving contact, suppose this moving contact, which when they pull down from the fixed contact, and after some time it moves out of the port through the opening, so that a complete arc extinguishing can be occur. Okay, so that is the plain explosion port. Okay, normally plain explosion port is used in low current fault, okay, low current application. The second classification is cross jet explosion port. Okay, cross jet explosion port. So figure 19.5, that is the figure of cross jet explosion port. Here the only thing is we are providing the arc splitter. Okay, arc splitter is there. So here we have two compartments, one is upper compartment and lower compartment, and two contact, fixed contact and moving contact, and oil is filled inside the port. Okay, and there is no opening in the port. Okay, so when the fault occurs, so during the normal condition, both fixed and moving contact, this is the fixed contact and this is the moving contact, are close together. When the fault occurs, this moving contact is pulled down from the fixed contact and arc is struck between these contact. Okay, so due to this arc, heat is generated and hydrogen bubble is produced. Okay, and when the fault occurs, the moving contact is pulled down from the fixed contact, and once it uncover the arc splitter, the oil is tend to flow towards the arc splitter. This is the arc splitter, vent of the arc splitter. So when the moving contact uncover the arc splitter, what happens? This oil is try to flow towards the arc splitter, and it cut the arc between the contacts. So cutting the arc or splitting the arc occur. Here splitting arc is occur, so that we can easily increase the resistance of arc and we can eliminate the arc between the contact. That is the function of cross-jet explosion port. So these type of contacts or this type of circuit breaker is used in heavy fault conditions. The next one is self-compensated explosion port. So figure 19.6, that shows the self-compensated explosion port. So it is the combination of first one and second one. So what is the first one? The first one is plain explosion port. So it is the combination of both plain as well as cross-jet explosion port. Okay, cross-jet explosion port. That is the self-compensated explosion port. Self-compensated explosion port. It is the combination of plain and cross-jet explosion port. So you can see that the combination of both circuit breaker. So you can see the upper part represent the cross-jet explosion port because it consists of arc splitter. Okay, so upper part consists of cross-jet explosion port and lower part consists of plain explosion port. Okay, so because in lower part it consists of a throat, okay, a opening, so moving contact which moves out of the port. Okay, so when the fault occur, high fault occur means the high pressure is developed here, so that before the moving contact is out of the port, what happened? Due to the high pressure, it extinguishes the arc between the contact. Suppose the fault is very low, it is very difficult to create a high pressure of hydrogen gas due to the low fault. At the time, the moving contact which moves downwards and it moves out of the complete port. Okay, so that is the operation of self-compensated explosion port. So during the heavy fault, the moving contact moves up to the arc splitter. It uncovers the arc splitter and it eliminates the arc at this point. When the fault is very low, there is a low pressure is created, so that the circuit breaker cannot be easily extinguish the arc inside the port, so that the moving contact moves away from the port. Thus it eliminates the arc. So that's all the self-compensated explosion port. Thank you.